Good afternoon, one and all present here. Today, my name is Sahil Patel, and I and my fellow colleagues Neil Patel and Pranay Patel have written for you a Python library, and we will discuss how OpenCV is used for image processing and for detection and for many other stuff for able to learn machine learning. It OpenCV is a huge open source library and it is used for computer vision, machine learning and image processing. If it is integrated with other libraries, we can like NumPy, like Keras, we can use it for many array structure analysis. So OpenCV comes with many advantages. It can be used for its mathematical operations can be used and its features can be used in image identification and patterns. And so yeah, let me show you the how the installation of OpenCV works. So OpenCV can be installed in any of the devices through Anaconda. So through Anaconda, in the Anaconda prompt, we can write the command and we can get the OpenCV. In Windows and Mac, we can install the OpenCV with the help of a pip library. So pip install and we can write the command to install the OpenCV. But if we want only OpenCV and without any extra modules, then we simply write pip install OpenCV in our Windows and Mac. And this command can be written in any IDE, that is like VS Code, PyCharm. So we can just go to their respective command prompts terminals and write this command so to download the library.
So some important OpenCV function which will be going to do is first is image read and save. So as we basically know that image reading and saving is one of the basic function and most required function in real life. So OpenCV2 provides image reading and scanning. Other than that, with help of Matplotlib, PIL and URL library, we can also do the same things. So this is the code for saving and reading the image. Next. So this is the output for saving and reading image. Next. Image rotation. So there are basically three phases of image rotation: 0 degree, 90 degree, 180 and 270, and 360 degree would be at 0 degree. So these are the code for different degrees. Like for 90 degree, we will write image cv dot rotate, then source, then cv2 dot cv2, and then image dot rotate dot clockwise, because we are going for clockwise. If we are taking uh, anti-clockwise, so it would be 90 is opposite to 70 degrees, so it would be 270 degrees. And this is the code for 180 degrees. So the 180 degree would be, in that we will rotate the image by rotate 180-degree function. So this is the image of parrot which is rotated by 180 degree. And the next thing is the code of 270 degree, in which we will use rotate 90 dot clockwise. So 90 clockwise will be 270 degrees. And this is the output of parrot which is rotated by 270 degree. The next function is image drawing. So with help of OpenCV, we can draw various shapes of images such as circle, rectangles, ellipse, polyline, and convex. So below, in this article, we have write two types of main part, which are circle and eclipse. So the first syntax of the circle is cv2.circle. Then these are the parameters. The image parameter will represent the image, center parameter will represent center of circle, radius parameter will represent the length of the radius, and so on and so forth. So this is the code. The main thing here, note that the cv2.circle and the image. So the images we will insert from the user, and 80.80 is the radius of the circle, and the another thing is the color of the circle and the length of the circle. So this is the output. So as we can see, the blue color dot is saved with in panda's picture. The second function is eclipse. So the syntax of eclipse is similar to circle, but there is a one or two parameter is changing, like thickness and shift. And this is the code for inserting eclipse in the image. And as we can see, the red eclipse is being done at the eye of the panda in this picture.
So next we will see about Kenny edge detection. So in an image, the points, what are edges? So in an image, there are points where the brightness of image changes sharply or has discontinuities. This is what we call edges. And edge detection is a very useful concept that is used nowadays very much. In deep learning models are gaining very much prosperity nowadays, and now, since for that object detection is essential, and edge features used to extract image from extract information from about objects present in image. It can also be used for image segmentation and image sharpening. Now, what is image segmentation? Segmentation means that the image is segmented into various parts. Like, for example, on a road, we have different vehicles. So how do we detect those vehicles? For that, image segmentation is used. Now, the Kenny edge detection is mainly done by many steps. It is a multi-stage algorithm. So the first step is noise reduction. Since the mathematics involved behind the scene are mainly based on derivatives, so the image edge detection is a very sensitive to noise in the image. So first part is to remove the noise. For that we use a Gaussian filter. Then after, in the second stage, we find the intensity gradient of image. Since edges correspond to a change of pixels intensity, to detect it, the easiest way is to apply filters that highlight the intensity changes in both horizontal direction and vertical direction. Then we can find the two images from which we can find the edge gradient and direction of for each pixel. After that, the third step is non-maximum suppression. So now that we now we want to remove the unwanted pixels. Since the final image edges should be thin, but at present we have the image which has thick edges. So we remove those unwanted pixels, and for this every pixel is checked if it is a local maximum in its neighborhood in the direction of gradient. Now the final step is hysteresis thresholding. Since we have the now we decide which edges are actually edges and which are not. For that we take two threshold values, mean well and max well. Both are taken from the user, and we compare the intensity gradient of each point that we calculated before and compare it with the mean and max well. If suppose the threshold value is intensity gradient is more than the max value, then it is surely an edge. If it is lesser than mean well, then it is surely not an edge. Now, what if the value is between mean well and max well? Then we take it as a weak edge, and for that we compare it the pixels nearby it, and if it is one strong edge, then we take it as a strong edge. So now this is the code for Kenny edge. We use the Kenny function, and then there are parameters. Like the first parameter is we take the path of image. After that, the second two parameters are mean well and max well. As I told you about earlier, these two filters are taken by the users and used for hysteresis thresholding. Then there is aperture size, which is optional, and the final parameter is L2 gradient. Its default value is false, but if we change it to true, then the Kenny function will provide us more accurate results. But at the same time, the cost of resources will also increase. So this is the code, and output, and in the output we can see that edges of the rose petals are clearly seen. So this is how the CanyEdge function works. Now let's discuss the opencv blur. Like edge detection, blurring is also a very important part of image processing. It is used to remove high frequency content such as noise, edges in an image. There are other advantages also, like to help it helps to remove low intensity edges and to smooth the image, and sometimes also in hiding details. Now, just one dimensional signals, image can also be filtered with low pass filters and high pass filters, that is LPF and HPF. HPF, that is high pass filters, are used in edge detection that we talked about earlier, and it is used for sharpening the images normally. And low pass filters, that is LPF, is used to reduce in removing the noise, blurring images, etc. Blurring an image is done by convolving the image with a LPF kernel. As discussed, it is used to remove noise. And in order to do so, edges are blurred a little bit in this operation. So that there are different OpenCV provides us different ways to do the blurring. First, we have OpenCV averaging. In this, we use the box filter, and we take the average of all the filters pixel and then replace it with the central element. This is CV2.blur, and in that we use the parameters. First, we take the path of source image, then we give the path of destination image. Then after that, k size, which is the size of kernel, is given. Then we give the anchor, which denotes the anchor points. After that, the border type will decide what type of border to be used to the output. And this is the code for that. And this is the output. As we can see that the image is blurred. And now the second function is that is opencv medium blur. So in this, the it is extremely useful for the salt and pepper noise in the image. In this we and this is very much similar to Gaussian blur. In this we take the median of all the pixels available in the pixel area and then replace it with the central element. And for that, syntax is this cv2.median blur. This is the function, and the parameters are less. Here we only provide source and image path, destination image path, and the size of kernel. And this is the code for it for that. And this is the output. Here you may not notice much difference between the last average filter and this median filter, but there are filters actually for which you need to go in depth. Now third is the OpenCV Gaussian blur. This is an highly effective in removing Gaussian noise from an image. In this technique, instead of box filter, we use Gaussian kernel, and standard deviation in X and Y directions is also need to be specified along with the height and width of the kernel. So this is the syntax. We use the cv2.gaussian blur function, and in that we use the parameter source and destination path are the fixed. We use them in all the functions. Kernel size is fixed. Destination image path is fixed. Two things that are sigma y shows the kernel standard deviation along y-axis. And lastly, we have the border type that is used to specify image boundaries. And similarly, this is the code for that Gaussian blur. And lastly, we have the output. You need to go in depth about the difference between these three filters. Then only we can come to know the difference between the outputs. Although they look the same, but there is a very minute differences in them.
Hello again. So my colleagues were successful in telling you about how to have fun with images, how to work with images, how to use various shapes and sizes, and how image processing and various commands in OpenCV works. Now I will show you some prerequisite functions that we can use in image detection. How if we are making a machine learning model or any detection project, so we can use these functions in our project. Like one of them is opencv capture. So opencv capture in so the command that we can use for opencv which is given is video cv2.video capture. So what it will do, it will help us use work with the camera. We can do following tasks, like we can read the video, we can display the video and save the video also. We can capture from the camera and we can display it. Now in this code I have converted my frame color to gray, and so that my background color whole image comes out in gray. And I've used I am show to show the frame, and the weight key is set to 1 so that the frame can be seen every 1 second. So this is the output. As you can see that the convert color to gray has been set, black and white. So now I will show you OpenCV display text. We can use this if we want to use any text written stuff in our project. Like we have to detect something and write the text for it by the AI itself. So we can use like something like this. We can create a black image. And then we can put that text on it. So we can put that text on that black image frame. So here I have used a CV2 name window. So it will create a window, and it will display the image and the text on it. And if we are using any machine learning project, so we can write like that. So we can add the path to the that file from which we are detecting the text and writing it here, or we can simply display the text that we want to display. Like here I will display processing. So as you can see, the processing is displayed in this display text. So now OpenCV can be integrated with different libraries to create a face recognition window. Like here, dlib is used with OpenCV. Dlib is like OpenCV. It is also a very great machine learning Python library. And what it will do, as we can see that we can capture our video and display it with OpenCV. And dlib has various inbuilt files that we can use for tools for detection. Like here, shape predictor face landmark file, which is like it has 68 landmarks, and this file is a pre-built for detecting the face. And we can first upload the image, our image, like the whole face. And we can also set that if we don't require 68 landmarks, we can also set and edit the dlib file, so that we can use accordingly how many landmarks to set. Uh, and we can set, like in the code, I have first imported the cv2 and dlib files. Other files are not that important in the current code. So we will first use the video capture function as discussed above, and then we will call the dlib file through the dlib get frontal detector and calling the file that is saved in our path. And then we will use other cv2 commands like converting the color, then create clahe. So clahe, what is clahe? So clahe is a contrast limited AHE. Like it is, AHE means adaptive histogram equalization. Like it is a variant of that. So what it does, it makes the contrast amplification limited, so that it reduces the problem of noise amplification. So it basically, in machine learning models, clahe makes all the images equalizes all the images and in small patches or small tiles with higher accuracy and contrast limiting. So it does that. And similarly, we will make IMShow command to show the frame. And so as you can see, like all the landmarks on my face are detected, and we can use this in learning about if we start a detection project. So as you can see, we learned about various image processing and learning with OpenCV, how it is a form of computer vision, and it helps computers to understand the content of digital images such as photographs and videos. And we can use this library to analyze the objects to for video and AI and image processing applications. And as we know that these applications are a huge prerequisite for our how world is moving forward in terms of artificial reality, AR, deep learning. All these are so starting with learning about Python and its libraries makes you makes you get set into the mindset of how these models work and how future is going towards. So thank you, and I hope me and my colleagues Pranay and Neil have given you an insight about how OpenCV works, and I hope you have enjoyed learning with us. Thank you.